Hey guys, in this week's video it's going to be a bit more conceptual and about deeper understanding, and it's going to be about the relationship between tangents and slopes and or derivatives, so to say. And I'll be showing you how to utilize the knowledge about tangents and how to connect it to slopes, to tangent lines, and whatnot. So first, let's just review what a tangent is. And a tangent is our opposite side over our adjacent side. So if we have a right angled triangle right here, and this is going to be a right angle, and we're going to have, let's say this is theta, then it's going to be our opposite side, which is this side, over our adjacent side. So our tangent is going to be this side over this side right here. And just as you may remember with the other trig identities, there's this word so, ka, toa, and toa tells you that it is opposite over adjacent. So just so you remember. So after this quick recap, we can now think how we can apply this to slopes and derivatives. And I encourage you to look at this triangle and think how you might possibly relate this to a slope, and then come back and watch the rest of this video. But if you're already there, then let's go straight into it. So first, let's look at our unit circle, because I really think it puts things into perspective. So let's say that we have a little line over here in our unit circle, and this is going to be our hypotenuse right here. Then this is going to be our theta, and then this is going to be our adjacent side, and this is going to be our opposite side. And in a unit circle, our x value, xy, so to say, is going to equal to cos theta and sine theta, because this has the value of 1, right? And if you're looking at this, then you can see that our slope, aka our tangent, is this line right here. And how you get this, how do you usually calculate a slope? Well, a slope is your change in y over your change in x. And here you can see that your change in x is this adjacent side right here, so it's your cos, and your change in y is your opposite side right here, which is your sine. So you can write your m, or your slope, as m is equal to opposite over adjacent, which is equal to the sine of theta over cosine of theta, which is equal to tan of theta. So usually whenever you're dealing with slopes and you have to connect it to trigonometric identities, you're always going to end up using tan, because tan is always this change in y versus or divided by this change in x. And that is all our slope is. It's always our change in y over our change in x. So whenever you're a bit confused, just come back to the unit circle and remember this basic idea that your tangent is the opposite over the adjacent, and the opposite is your change in y, and your adjacent is your change in x. Now let's elevate this a little bit more and connect it to tangent lines. And again, we're going to do the same thing. So for example, if we want the tangent line at this point right here, and we know that it connects to the x-axis, we can create a triangle right here, and say we're given that the tangent line makes an angle of, what do I know, pi over 6 with the x-axis and y-axis, so to say. So this is how it looks like. Well, then you want to find the slope of the tangent line, right? And so your slope is going to be, again, your change in y over your change in x. So this is your change in y, and this is your change in x. And again, if you recognize what a tangent is, you realize that this relationship is represented by tan of pi over 6. Because all tan of pi over 6 is this opposite side over this adjacent side. Now this is a really nice example, but in mathematics, we have to be a little bit more creative sometimes and learn how to adapt. So therefore, I'm going to show you this other example really fast. And that will be if, for example, we want a negative tangent. So let's say that this is our tangent line right here. Well, then our right angle is here. And then let's say that we're given the information that this angle right here is pi over 6 and not the other one. Well, how might you go about solving this? Well, this is your change in y, and this is your change in x. However, And this is where it's important to come back to the unit circle, because this slope does not equal to tan of pi over 6. And why might that be? Well, if we draw our unit circle and we have an angle of pi over 6, which would be somewhere here, then obviously we're going into the wrong direction, because our slope is going to be positive, but here it's negative. So while you can simply just say that the m is equal to negative tangent of pi over 6, you can also explain this a bit more rigorously in the sense that this right here is the same thing as drawing this triangle right here, where this is pi over 6. And this is your change in y, and this is your change in x. And we can express this right here as the tangent of pi minus pi over 6, or tangent of pi minus theta. And again, I've used pi over 6 just as an example, but this is really just any angle. And if you come back to the identities that you know about tangent, sine, and cosine, and if you're a bit unfamiliar with them, you can check out a video that I did on that and how you understand these sort of identities right here, which are a bit more conceptual and tricky sometimes. Then you know that tan of pi minus theta is the same thing as negative tan of theta. And this is again because tangent is equal to sine over cosine, and here you would have a positive sine and a positive cosine, but here you would have a positive sine but a negative cosine, so your tangent is going to be just the negative of this tangent right here. And so here, if you're looking for the slope, you have to adapt, so to say, and recognize this is the negative tangent. And again, you can repeat the same process for all other quadrants. For example, if you're finding one right here, or if you're finding a tangent line that goes this way, for example, if you're finding a tangent line that goes this way, then you don't need to actually convert anything, because you can just pretend that your unit circle starts here, and so on and so on. So all you're doing is you're creating these triangles which represent the slope, and then when identifying the angle, or whatever angle you're given, you're working with that angle in order to figure out what quadrant this triangle is in, and therefore what the tan value is, because the tan value often and almost always reflects some type of relationship with the slope. And then from here you can work out the slope, and if you know, for example, the derivative of this at this tangent point, you can find out a variable that you want, and so on. So I hope you enjoyed. I hope you understood the relationship between tangent lines and tangents. I mean, the tangent line is called tangent for a reason, right? There's obviously a relationship. So when in doubt, always come back to the unit circle and try to visualize your tangent lines in this quadrant right here. And keep on practicing, and see you next week.